And let's see here. Yeah, string concatenation. And okay, and so we've talked about this before. Of course, I have a little bit of a hard time seeing. Yeah, so let's see here. Sometimes Zoom covers my screen. I can't always see what I'm doing here. Okay, so here we go. Okay, so here's just the review. Okay, so string concatenation is when basically when we're redefining what, and again, students call out anytime, either via chat or just unmute yourself and ask a question. It occurs when we add a string to another string or to a number. So we're redefining, we're extending. We all know what addition means when we're adding numbers together. And it has that same meaning in Java. You add two numbers together, it's just like adding numbers together in any other math class. But now what we're doing is we're adding numbers to a string. Like there's that example, and it's called in this case, this is called addition is called an over. In other languages like C++, it would be called an overloaded operator, meaning we're changing its original definition. So instead of just adding numbers, it means something, we're extending it. And so in this case, we're adding that string ABC. Does everyone see where I am right here? ABC plus 2. And we're just combining them together, right? So we're just turning it into one big string. So we have a string plus a number, and now we get that string there, ABC2. So this is something maybe I feel like maybe we haven't talked enough about in class. Well, okay, so let's say we're adding a bunch of numbers and then a string, or a string and then a bunch of numbers. So this is mostly what I wanted to get at here. And so you have 1 plus, because sometimes we can get unexpected results. So we have 1 plus 6 plus ABC. So it's just like in our regular math courses. There's two operators at the same level of precedence, two additions. So we perform the additions from left to right. So the first thing that we do is we add the 1 plus 6. So if I was going to do, this is basically, if I was going to put parentheses around this, it's the same as this. And then I'm not going to get the same double quotes if I do it like this, but that's the idea. We do the 1 plus 6 first, because we're going left to right, and then we'd add on ABC. So 1 plus 6 is 7, and then we get ABC. Okay, so now we're adding the numbers. We have a string, and then we're adding the numbers. So when you just have numbers, it's just like regular addition, and everything changes once you get to a string. Okay, so now here we have it'd be ABC. This is the first addition that would occur. ABC plus, because we're going left to right. That's the first addition. And oh, I'm sorry, plus 1. And then plus 6. And so now, so what do you get there? You get ABC1, right? And that's how you get that ABC16. Hopefully I won't go over the line. I probably will. Yeah, it didn't like me. Okay, so. So you can get this unexpected result if we're not careful. Really, the way to fix that would be to put parentheses around 1 plus 6. If you really wanted ABC 7, you'd have to go like ABC. And now you'd actually, because of the parentheses, then the 1 plus 6 would occur first. So just remember, we still have to do the additions left to right. And yeah, so I used to, if it was like an exam in a classroom, I might give a problem like this. I don't think I do it on the Canvas quizzes. But just to be aware of that you can get funny results if we're not careful. And so then I have a couple of worksheets. Maybe we'll just do one of these. So here, maybe I'll let you, okay, so let's see, students, I'm gonna have to reload. I didn't mean to put all that in there. Okay, so I'll upload that worksheet again. Okay, but yeah, so here, I think we get, okay, we have a string. Does anyone see I'm in that problem 1? Right there, find the output.
Yeah.
Yeah, so we have a string and then a number, right? So the 1 plus 1 equals is in the So we just echo exactly what's in the string. It doesn't matter what, then equals, and then you, okay, so that's normal. So that's kind of what, that looks like a decent output. And then here, we do the addition, we go left to right, we see have two addition operators, but it's 1 plus 1. And so that's just 2, and then we concatenate on. Remember, we just combine. And so first we have the 1 plus 1, we get 2, and then plus the string equals 2. So when it's a string plus a number, we just kind of combine them. And then that's the concatenation. But here's where we can run it, we run into bad results. So we get 2 equals, but then the first addition is plus 1. Remember, so the first addition, remember, what we'd be doing is 2 equals, that's our first addition. Right, so we get this funny result. So we get 2 equals, and it looked like 2 equals 11. So, all right. So, any questions, feel free to interject at any point. I just wanted to make you aware of that. And I don't know whether the ZyBook, I can't remember whether the ZyBook has any exact problems like that. And again, even in Math 130, this is the kind of thing I maybe test at the beginning, maybe it would be on the final. But I don't think I'll put it on any of our quizzes, but just be aware, if you're writing a code, you might get some funny output. If you add if it's string plus a number, that's when you get the funny output. When it's like number plus a number, and then the string, you get the correct output. So once you add on so when you're adding numbers and strings, like here, let's go back up here, 1 plus 6 plus ABC, it's just regular addition until you get to that string. But once you add on a string, then everything after that is a string. So why don't we do this kind of fun problem? Maybe we'll just do number 2. I don't know. We have plenty. I definitely want to get to arrays, which is a very important topic. Okay, so but let's just try this first one, and then maybe I'll let you try the last one on your own. Okay, so first name is, okay, so we're reading in, there I have an example here. And so maybe I should have maybe denoted this better. I'm going to re-upload this worksheet because I had an error in there before anyway. Okay, so there's our code. So the code starts there. And we want to display the names in reverse order. So, and we want a comma in between. So we're going to have to do string concatenation. So here, let's just try this. System. So we're going to first add on the last name. And see, now we're going to add on, I know the double quotes don't come out quite right with Microsoft Word. We're going to add on a comma. There's no space after last name, and then there's a space. And then you see, so that, again, that's where the string concatenation is really quite useful for punctuation, for like putting commas in when we need it. A lot of times our output is a sentence. We want a period on the end. So so the very last thing has to be like plus and a double quotes period. So I'll eventually maybe I'll even add on some more problems to this. And then I'll put a solution file. So, and do you remember there's a method. We haven't looked at this in a while. Remember there's that caret. So if you want the first initial, you're going to have to use the caret. But I'll let you try number 3 on your own. But are there any questions right now before we stop sharing? So anyway, it doesn't hurt to review. Sometimes we see things at the beginning of the course, and then you don't see them again, and then 5 weeks later, it's like, what? I don't even remember this. Okay, so stop sharing. Okay, so students, just remember there's this folder. I didn't create a module yet. There's a folder called I think lecture 12 arrays, and and that's where I'm taking my, that's where I'm taking, I have a couple files up there dealing with arrays. One is just this lecture note on arrays. There's a worksheet. Um, I'll post a quiz on Wednesday, which you can, then you can have a few days to work on. The worksheet will really help you. Also, some of the ZyBook problems will help you too. Um, but let's just get to arrays. Okay, so now I'm going to open up the PowerPoint slides. Whoops. Yeah, I know I don't. Yeah, better if I did a very share screen so you can. Okay, so there are PowerPoint slides. I think it's called array 1. That means there better be an array 2, I guess at some point. There is. So I got an email over the weekend saying, hey, what should I do to prepare for, someone who wants to major in computer science? What should I do to prepare for Math 140? So I think this last half of the course, everything we're doing now will prepare you for Math 140. But this last 7 weeks, I think, will be the material, it kind of accelerates the level of difficulty. And that's the thing about Math 130. It kind of starts out, can be kind of slow, and then you get to arrays, which is kind of a hard topic. And then there's methods, and then there's object-oriented programs. So these last 7 weeks or seven, I guess it's 8 weeks, but we also have a couple of days, one day off. We have that, I forgot, Veterans Day off. And then, but it gets, I think the amount of material that at the end is, like any course, is harder, but I think especially in this course, it kind of really, it just, if I was going to graph the whole difficulty, I think it would be an upward concave up curve. Okay. At the end of the lecture, again, just go to lecture 12 arrays at the end, and I'll put a module up here for this soon. At the end of the lecture, you'll be familiar with the following material. We're going to see why we need arrays, how to declare an array, how to use an array, and common errors involving arrays. And so arrays can make us, this is definitely something we want to keep up with because it's going to be hard to continue in the course, because you're going to see this throughout the rest of the course. And also you see this in Math 140 a lot. So the idea behind it, let's say you have a lot of variables with like similar names. Let's say we're writing a grading program. And so, we have maybe 3 tests. So you declare, and you want to do statistics like average or best, highest grade, lowest grade, or whatever. And so you declare 3 grade variables. Okay, but then what happens if, okay, so you teach this, so then you want to revise this program. Oh, and all of a sudden we have 6 exams in the course. So wouldn't that be terrible? An exam with a course with 6 exams. But anyway, then you go back and you change your program, which is not good. If you have to, you can leave, it can be, you can actually introduce errors. You want to edit your program as little as possible. Once it's working, you don't want to. Sometimes you do. You do have to go in there sometimes to add new features, but if it's a real, program that's used a lot. But of course, there's always that possibility you're going to introduce errors. Okay, so what we're going to do is, so here we have like these 6 variables have the same meaning, but they store a grade and they're numbered. So how can we do that? Let's say we have 100 exams, or something like that, or 20 exams, or something ridiculous like that. Okay, so we use arrays. So an array, so it's a variable that stores a fixed number of values of a single type, and so the number of values is there's actually for every array there's a property called length, and that's fixed. Once we declare an array, the length is fixed. So why don't we just look at an example here? Okay, so there's a couple of ways we can declare an array, and so this is what's new. Do you see that square bracket? We go int square bracket exams, and that square bracket means array. And so an array is like a list. You've actually seen that square bracket, like in the main method, you have a string square bracket args, and it means that args represents a list of strings. And we almost never do this anymore. But when we run our programs, we can actually get data from the user by we say the name of our program and then we follow with like a list of strings, and that list of strings goes to the args. Like that's how we get that goes to the string args in the main method. But we never do that in this course. And it's rarely used. When I did programming like 1,000 years ago, yeah, we did that. Okay, so Okay, so we see int square bracket exams, and that means exams is a list of integers. It's so when you see that square bracket, yeah, it means array, but you can just think of list. An array is just like a list. And then, but it doesn't actually, we haven't said how many elements are in that array. So in the next statement, we're saying how many elements are in that array. And so we can actually do this on two lines. One line, we declare the array, and on the next line, next statement, we say how many elements are in that array. Okay, so when you see that new, and I don't know if we've seen new a little bit, like when we do scanner, and we'll see new a lot. That's the one thing about Java, like right away you're doing this kind of, using these words that like, what? They're kind of advanced terminology, but you almost have to do that from day one. Okay, it just means we're allocating memory. New means to allocate memory. And so what we're doing here for this array called exams, we're allocating memory for 5 integer values. And at the beginning of the course, something more you do in Math 230, every integer, an integer value is stored in 4 bytes of memory, 4 bytes in the computer's memory. So that's not something you're tested on, but remember the computer's memory is that's where we store all the numbers and everything. So an integer is assigned reserve 4 bytes of memory. So here we're allocating memory for 5 integer values. Okay, so let's just look at some more information here. So there we go, we declared our first array. So basically, okay, yeah, so the first statement, yeah. So when we just have that first statement alone, this is what I'm talking. Let's say we're just at this point in the program. We're just going to compare just look at the first statement. So we've declared an array, and it can store, this type of variable can store a list of integer values, and there's that brackets that say we have a list or an array. But we don't exactly, just from the first statement alone, we don't know the number of values stored in the array. It's the next statement. See, this tells us, this basically kind of just repeating what I said. So this is the one that says, okay, allocate memory for 5 integer values. And you can put any positive value in there that we want. Okay, so then, so let's just, so again, just remember, if you have any questions, just let me know. Okay, so the values stored in an array are known as array elements. And and we need an index to refer to an array element. And the index will be the number in the square bracket. And so the smallest element, computer scientists like to start counting from 0, just like in a string. The leftmost character is at position 0. So in an array, the first element, the first element in the array is at index 0. So I don't know if you in your algebra courses or calculus, you've talked about sequences like a sub 1, a sub 2. An array is kind of like a sequence, and the first element in the sequence is at subscript 0. Okay, so students. Okay, so here comes the really fun part, students. Okay, so if you go back here, we allocated, so in our example, a few slides ago, we declared an array, like back here, slide 6, right? We declared an array with 5 allocated memory for 5 integers. And now what we're going to do is, just at random, there's nothing special about these numbers. We're going to assign a value to each one of those array elements. And again, there has to be an index. This is how we reference an individual element of an array. We say the name of the array, then it's followed by square brackets, and then we have to put a number in that square bracket. And that's how we distinguish between, here's element 0, here's element 1, here's element 2. So the number that goes inside the square bracket is often called an index. Okay, so the value stored at element 0 is 90. Yeah, so the very first index is 0. So the very first index of any array is always 0. And of course, which means the last index is 1 less than the length than the number of elements in the array. So we had 5 array elements. So the last one is always is 4. So the very first element is always at position 0. The very last element is always the length, which is the number of elements minus 1. So remember, okay, so this would actually generate, if we actually ran our program, these statements would generate an error, because remember, the first element is 0. The only valid indices, we had 5 elements, right? So we declared an array with 5 elements. So the only valid indices are 0, 1, 2, 3, and 4. So if we actually tried to go, so if we can't put a negative number for the index. Well, definitely that's an error. See that 5? Well, that's one more, right? Okay, so the greatest index is 4, right? Because the first one is at 0, 0, 1, 2, 3, 4. Okay, and that's 5 elements altogether. Only that 100 is way too big. It's crazy. So yeah, so anyway, so this, what I mean by runtime error is that the problem won't arise until you actually start running your code. So far, it hasn't been too bad. So students, I just want to show you, there's other ways of, that first example, the one in slide 6, let's just go back up here. We declared an array. I took 2 statements. First, declare the array, and then allocate memory. And we specifically say how many elements are going to be in the array, and that's fixed. Okay, but I just want to show you can actually do it on the same line. This is probably more common than example 1. Okay, so so look at that. So look at example 1. The name of the array is AVE. I guess that's supposed to mean average. Okay, and then, but notice, okay, so now, but what kind of it's going to be a list of doubles, right? So again, whenever the first time you declare a variable, you just look to the left and it tells you everything you want to know about that variable. And then the computer remembers that we definitely don't, declare it again. So what this would mean is that AVE is a list of double values. Just like exams, that one on slide 6 was a list of integer values. And we can have an array of any kind of variable. So what do we learn to learn? We've learned about doubles. We've learned about int. We've learned about string, with the uppercase S. And we've also learned about something else, which car. Car, yeah. Maybe I should have notes in front of me. Car, I couldn't remember that. Okay. So any kind of valid variable type, in the last 5 weeks of the course, we're going to learn how to create our own variable types. That's the object-oriented programming part of the course, and we can create arrays of our own variable types. And so, and then we'll go over. Then we have our holiday break after that. Okay, so okay, but that's we got 8 more weeks of this. Okay, so AVE is a list of double values. Okay, and once again, in example 2, nums is a list. That square bracket means list of double values. And then we allocate the memory on the next line. So we can either allocate the number of elements on the same line or on 2 separate lines. And I'd say this first example, you see both, but I'd say this first one is probably more common. Okay, students, now I just want to show you something else here. I noticed there was one semester where students kept doing this. I think to the point where I told them to stop doing it. You could actually put the square brackets after the variable name, and I don't know if it's the core, if it's for, it was some concession to C programmers or not. That's what I once read. So you can do both, right? As I say, you can see. I'm declaring. See, ARR is a list of integers, and what I'm saying is that you can put that. See, there's 2 ways of doing it. It's int ARR square bracket, or down there at the bottom, it's int square bracket ARR. And I will tell you, students, this is what almost everybody in the world does. I almost never see this. Occasionally I'll see it. I don't know if sometimes when I see that, I wonder if the person is like done a lot of, they're used to C programming and they just keep that habit there. But I think almost every book will have what I have there highlighted in bold. And so I'm going to ask just, I think that's a good way of doing it. That's all. Just because it's more the norm. So, but yeah, you might see this, and I've seen some examples where they do the square bracket after. And tell you, I think a couple times I'm typing too fast, so I do that, and I'm not thinking. Okay, so students, here's any. So again, we haven't really done too much, but I think it's kind of we've introduced a lot already. So students, the one thing I want to tell you is that if we have an array of like a number, like an array of doubles or an array of integers, every array value has a default value, and the default value is 0, right? So if you don't actually initialize it, so if we say, okay, here's a list of 3, here's an array of size with 3 elements, initially every value is 0, and if it was an array of doubles, then it would be 0.0. So when we declare an array and we allocate memory for it, there will be an initial value for all those array elements. But students, let's say we're declaring a short array, like maybe not a lot of elements. We can actually initialize every value when we declare the array. So here's just a new way. So this is totally new right here. So here's a new way of declaring an array right here. So I don't want to use the word new. New is a key word. So how about another way of declaring an array? But so this is kind of what's new here. So here's this array. You see that it's a list of 5 numbers. So okay, so scores is like so this is good if we're declaring an array with this a few number of elements and we want to initialize every value right away. Okay, so in this case, that array has 5 elements. And so you do it, so on the left side, we have an array name, and it's called scores. And again, we know it's an array because to the left, we see that square bracket. Scores is a list of integers. And on the right side, we actually say what those integers are. So again, the numbers are separated by commas, and then they're surrounded by the curly braces. Because I mean, if you had 100 elements in your array, that would not be very useful. And so let's just print out, maybe I think I'm using something here that I haven't talked about yet. Maybe I don't think I've talked about that length property. Okay, that's great. We added this slide last night. Okay, but let's actually, if we want to print it, let's just print out, let's use a for loop to print out every value. And I realize, students, I don't think I've actually talked about that right there. But we did talk about, we have talked about for loops. And we will get to that length property. And so length just tells you the number of elements in your array. And every array has, since I've used it, every array has this built-in property length. So we automatically know the number of elements in an array. Right? And so remember that the very first element, so this is kind of your typical for loop header. So yes, this is the first time I've done this. And we're going to talk about this a little bit more, but yeah, you always start at 0 because 0 is the first index, right? And we don't want to go all the way up to length because the last index is length minus 1. But I think I have some slides more on this later. I think the point I was trying to get here we're initializing this array scores, and it has 5 values. I go, okay, well, let's just print out. If you actually print out all the values, that's what you'd see: 11, 34, 45, 1, 100. I think I have some more slides in here that'll emphasize that for loop. Yeah, here it is. Yeah, so don't you like it when books use stuff before they actually explain it? Okay, so every Java array has a property called length. So here we declare, so this maybe is now getting kind of familiar to us, that very first statement. The array name is just any valid variable name. And we look to the left and I see int square bracket. So list means a list is a variable that can refer to a list of integers. And on the right side, we declare the number of elements in that list, and it's 10. So this is why, I guess I say this is what's new, but I just talked about it. There's this length property. And so, then there we see our friend string concatenation, right? And then, so we always know the number of elements. And so we just have to memorize this. It'll really save you a lot of aggravation if you just, we'll hopefully have exercises to emphasize this, but the number of elements in the array is, you say the name of the array, and then you go period, and then you go length, and there's no parentheses. So it's what's called a property of the array. So the output would be num elements in list is 10. But if we change that 10, let's say to 100 or 50, the output would, the length property automatically reflects whatever the length is. So we never have to compute the number of elements in an array. And I think like in C, like the C language, you do. So I'm just going to go on unless there's any questions here. So this is, okay, so how can we assign values to the first and last elements of an array? So let's just use the array on the previous slide. We don't even need to know the length. So 0 is always the first, right? 0 always means the very first array element because we count from 0. And now that we have this length property, so length minus 1 is always the index of the very last element. So let's say if an array has 20 elements, 19 is the last array element. Or if it has 100 elements, 99 is the last element. So if it has 100 elements, the indices go from 0 to 99. So in here, like in this example, it has 10 elements. So the indices would be 0 through 9. But you don't actually want, a hard, see this example, the one I'm going to just highlight this. You don't actually want a hard code that put a 9 in there because for, inside the square bracket, because what if you change the number of elements from 10 to, let's say, to 20? See, if you change it from 10 to 20, the last index is still list length minus 1. Yeah, so in this case, the length is 10, so length minus 1 would be 9, but it's just better. I know it's kind of, this is why I think computer programming might be a little bit hard. This looks maybe a little hard to read. It's list, left bracket, list.length minus 1, right bracket. So this is why, computer programming, it's a language just like, any language. There's all these kind of rules that at first might look kind of difficult or off-putting, like, oh God, what is that? List, square bracket, list. But if you look at it enough and you practice enough, it does get easier. And I know I look at a lot of symbols and, I'm learning some new feature of some language and there's all these symbols and yeah, it's kind of, at first might be, oh my God. But so if this looks hard to you, students, I really think if you study it enough, it'll get easier. Yeah, but it's very abstract, right? There's no number actually in it. We're actually computing the index instead of actually putting an actual number there. And so the other thing, students, that this is where I think it gets hard. Whoops. We don't want to get rid of it. We like this slide. Slide 19. So, okay, slide 19. Remember we saw length, we didn't actually see it a lot, but like a week or two ago, and I probably should emphasize this more in an assignment at some point soon, we talked about these access method for strings. This, like a string has like a caret method, tells us an individual character, and it also has this, what's called a method called length, but it's followed by parentheses, and it tells you the number of cars in that string. Okay, so here, so if we want to know the number of elements or the number of characters in a string, it's always the variable name is str, so it's variable name dot length, but then you have to put the parentheses in. We actually haven't learned about methods yet. That's our next big topic after arrays. But that length would mean it's like a function in math. But that length is a method, and every time you call a method, you have to follow it by parentheses, even if you don't put numbers in it or anything in it. Okay, but if we want to know the number of elements in an array, like here, the word is an array. Word is a list of cars. If you want to know the number of elements, we go, array name dot length, no parentheses. And that's the kind of thing, if you're new to programming, and maybe it can kind of drive you crazy. One has parentheses, one doesn't have parentheses. And it just comes with experience. It's just like anything. You do it enough, you go, oh yeah, big deal. But at the beginning, yeah, I think it's intimidating. It's all these, a lot of minute rules. Oh, so students, so here, I kind of jumped the gun with what I was printing out before. So what's the great thing about arrays? And so we've learned about for loops. We learned about for loops last week. And now we have this thing with arrays. And they typically go together. So some of the for loops we saw last week, well, we couldn't really do a lot. But once you have arrays, then you can start doing a lot with for loops, because it's an easy way to look at every element of an array. Let's say you want to sum all the values, or take all the average of all the values, or find the greatest value or the smallest value. So let's say we want to initialize every value of this array called numbers to 1.0. So remember, initially, so numbers, again, so I'm right here. So I'm right there. So number, we know it's an array because we see that square bracket. So numbers, we can look to the left. It's the first time we've seen numbers in our computer program. We look to the left, and we see that square bracket. So numbers is a list of double values. And how many? Well, it's 1,000. And the initial value of any array that's like a numerical type, like double or int, is 0. So every value of numbers is 0.0. But let's say we prefer to have every value be 1. So let's look at an array. So remember, I'm in a loop, a for loop. Okay, so remember the for loop is 4, and then you have the set of you have the parentheses, and you have this initializer, and then you have a Boolean expression, and then you have the increment. Remember, the initializer is just done one time. So if you want to look at every element of an array, so k will actually represent the index variable, but there's nothing special about k. A lot of times you see I or j, okay, I use k. So okay, so but index is another good one. Okay, so but we're going to start k out at 0, because that's the first index of an array. Okay, so here's our Boolean expression. You check to see whether the counter variable k is less than the length. The length is 1,000. And remember, in this case, the indices run from 0 to 999. So the first time, yeah, so numbers of 0 is assigned 1.0. You come up to the incrementer. K, remember that k plus plus increments k by 1. So now you check, it was 1 less than 1,000, and it is, and so forth. Eventually, k will get as high as 999. 999 is less than 1,000, so numbers of 999 is 1.0. You increment the k one more. Eventually, k is going to get the value 1,000, and that's when you want it to stop. That's why we have the less than. It's really common to see this, using less than instead of less than or equal to. So when 1,000 less equal to 1,000 is false. So eventually k is 1,000. 1,000 less than 1,000 is false. We stop. So this stops when k is 1,000. I'm just going to type something in here just briefly, and then I'll go back. We could also do it like this. But I'm sorry, I kind of went over here. Just kind of, that's not easy to read. Let me make that a little smaller. Let's see if this. Okay, you could do it like this, but this is kind of, you never see this. See what I have right here? I don't know if it's actually bad. It's just not the norm. It's just, we don't see this. So I'm saying don't do this. What I had before was actually, maybe let's see if I can fit this into this slide here. This is what you always see the less than. That's more the norm. And what I see in the comment is not, it works, but you just never see that. So if you do it like that, then it kind of looks funny. That's all. I mean, I guess that's maybe, I'm not sure that's a good reason. I guess I'm telling you it looks funny. So I mean, is that really, it just isn't the norm. All programmers do it really like this. So if you do it like this, it kind of makes it look like, oh, I don't exactly know what I'm doing. So anyway, so any questions on that, students? So there's a lot of that in computer science. There's a lot of things at work that we just don't do because no one else does it. There's this kind of agreement, unspoken agreement, students, like, like variable names start with lowercase characters. And the class name, like when we go public class, that term after class starts with an uppercase character. So there's all these little rules that are not actually built into the language, but just somehow programmers have kind of agreed to use that. Okay. Also, students, I just want to remind us of something. I wrote the for loop like this. I declare the counter variable inside the loop. And that's actually, to be honest, students, the norm. And I went K++. And I almost always see, I very rarely not see a K++. But I just want to remind you, the Zybook does it like this. It declares the counter variable outside the loop. That's the one thing they do a little bit different. And it's actually not the norm. They do it because they think it's easier for new programmers. And, maybe it is. Maybe they've done research and they found that. But eventually, the only reason I don't like that, eventually you're going to have to do it like what I do there on slide 20. So
the output for slide 20 is just going to be 1 through 999.
Yeah, if we actually printed out every value in numbers, it would actually be one. It would be 1. If I printed out numbers of K, is that what you're asking, Richard?
Yes.
Yeah, it would just be 1.0 over and over and over again. Okay. See every value of, so if we went like, let me see if I can squeeze that in here. Yeah, so okay, so I'm losing some of it. But if we went like this, it's the disadvantage of this PowerPoint is whoops, that's not good. Yeah, it would print out 1.
Okay.
Because every value is 1. Now, if we print it out, how about this? If I print out, let's see if I'm kind of losing some of the slide here, but let's see here. Okay, so let's say, I'm going to squeeze one more thing in here. How can we get the 99, the K and the, so if I went like this, K plus, oops, let's just make this all a lot smaller. See, if we went like that, then it would shoot. Okay, so I'm not going to move the screen anymore. It's not Microsoft Word. Okay, so but if you look in this loop right here, now it would print out the index and then the value. And so so first it would print out like 0 and then the space and then 1.0, and then it would print out 1 and the space and then 1.0. So there you would see the 0 through 999. And then after every number, you'd see 1.0. You'd see the index, and then you'd see the actual value at the index. So if you think of like a function in, like you've learned in your algebra courses, the index, like the number that actually goes into the square bracket is like your domain. And the number that comes out is like your range. So the index is like the x in f of x. Hopefully I'm not confusing you. And the number that's actually stored in the array is the f of x.
Okay.
I'm not sure if does that help a little bit? Or?
Yeah, it does. Thank you.
So any other questions before we continue? So I have a little bit more to go. Okay, so there we go. Okay, so students, now let's look at a few. I have a few things in here. And then we'll do a couple worksheet problems, and then I'll put the solutions up, and we can review some of those next time. We'll do some reviewing at the beginning of the next hour next time too, and then we'll continue on with arrays. Okay, so common runtime error. I see this a lot, and it's this right here. This is not our friend right here. Do you see what's happening here? Eventually, I is going to be 100, right? I starts out at 0. Okay, so ARR of 0 is 1, and eventually ARR of 1 is 1. Eventually, and every time you go through this loop, you increment I by 1. Eventually, I will be 100. And then because it's less than or equal to 100, the length is 100. So 100 less or equal to 100 is true. And eventually what happens is you try to do this. ARR of 100 is assigned 1. And there's your error, because remember the greatest index is 99? The indices run from 0 to 99. So this can be kind of a common error at the beginning, is to put less than or equal to instead of less than. But so anyway, I just wanted to warn us about that. So this PowerPoint slide is pretty sensitive. Okay, so there's your first error. Just be careful when you do, this is a common error, and then you have less than or equal to, yeah, you're going to get, and the compiler will not catch this. So if you're typing your program up and you do this, you're not going to get that red dot. So the compiler does not check our index. Okay, but the runtime environment does. Go, oh, there is no, you can't put 100 in there. The greatest value is 100. And so your program crashes. You actually will see a message on your screen like array index out of bounds. So maybe we'll try that in a minute here. Yeah, so let's go to, we'll try some of this in a minute just to see. And then, whereas if you're programming in C, C doesn't even check the index. So yeah, C, you can just run all over the computer's memory. Okay, but Java is our friend. And it says, okay, I'm going to check your indices to make sure you don't go way out of bounds. Okay, so Java will not let us put any other index in here other than 0 through 99. Oh, so what I'm saying is, if you actually ran this code, you won't discover the error until runtime. Okay, oh, so students, and I meant to not put this up. I wonder if I put this up in the slides. Yeah, I meant to take these slides out. I have a separate thing on this, so I might wouldn't be great if I paid attention to what I was, I edit the slides and I need to take stuff out, I forget. I actually have a separate file for this. So I'm going to, we're going to talk about this in a minute. Okay, Susan, anytime you want to leave, I'm not, you're not hurting my feelings. I encourage you to stay. I'm not kicking, I don't want anyone to leave, but if you feel like you have to go somewhere or it's enough for you for today, I'm not, you're not hurting my feelings. Okay, students. So this last part is about an array actually stores an address. I created a separate file last night that we're going to look at. So I'm going to make sure that this is not, I think I did upload this, and I'm going to actually re-upload the slides and take this out because I have another file that I think is actually better than this. In my own humble opinion, I think it's better. So anyway, so I'm going to stop sharing this unless there's any questions. I used to do this. I'm sure it confused everybody. I'm going to stop sharing. Let's actually share. Let's just do one or two. Let's do a little bit of programming, and then let's go back to that memory address thing. And then maybe we'll look at some of the. Let's try maybe one of the. I'm going to go back and forth a little bit. So I'm going to share Eclipse, and let's just do one thing with Eclipse. Let's verify that error, that array index out of bounds. So let's create a new file here. Let's put in this concatenation. So everyone should be able to see Eclipse now. Let's just create a new file. I don't know what to call it. Let's just call it, lack of imagination, I'll call it arrays. Oh, it's probably not a good name. I mean, it doesn't matter. There's actually I'll just use it for this. This will be fine for now. Okay, oh, I should have told it to do the public static void main. And so Eclipse, Zoom kind of gets in my way, so I'm going to just move this down so I can see what I'm doing. So let's just declare an array, and let's just how about 70? It doesn't really matter. And okay, so now let's just try. Okay, so we're going to do, see what I'm doing right now, students? It might be a little small. this is your typical for loop header when you're working with arrays. You initialize the index to 0, the counter variable to 0, and that middle expression is always counter variable.array.length. And so the sooner we get used to that, the better. I've seen students really, even after several weeks now know this. So this is the kind of thing that if you learn, the faster they'll learn this, the happier you'll be. Okay, so, and let's just initialize, I don't know, how about ARR of K is just equal to K. Okay, so, and then let's just print out the values here. And then we'll do some string concatenation. So now we're going to just, it's going to be a lot of output. Okay, let's do the system .out.println. Let's go ARR. I'm doing it in the double quotes, and then I got a square bracket. And now I'm going to go outside. This gets a little bit of a mess. I'm going to go plus K. That's our index. Plus, and now the double quotes again. Right bracket equals, and I'm putting spaces in. And again, if we're new to, I think I've done this enough, so that wasn't too hard for me. But I don't know if you can see like that line 18. I think that's if you're new to this, it's kind of challenging. You do it enough, it's not so bad. So let's just run the program and let's see what happens. Let's see if I've made a mistake or not. So it's a lot of output, so we don't see the whole thing. But yeah, you see array of, we see the ARR, we see the index, and then we say equals whatever the array value. We assign, basically we assign K to ARR of K. Not the most exciting thing. But now let's generate that error that I was talking about before. And I'm going to, let me make this smaller, 7, so that we don't get so much output. And see, notice students how I, like on line 11, I just changed the number of elements in the array. I don't have to change anything else because I didn't hard code 7. I didn't say K is less than 7. I used ARR.length. I used this abstract version to represent the length. I didn't actually hard code it. So now I don't have to go through the code and change everything. Okay, so just that. So all I had to do is change that one statement to change the number of elements, and the rest of the program stays the same. But now what we're going to do is we're going to print out all the values. But let's see what happens here. This is going to run so fast. You're going to see that error. And see what happens, array index out of bounds. And even you can click on this, it'll tell you exactly where it occurred. Right, so this is the problem. On line 17, the problem is it generates that index error. Yeah, so when K is equal to the length, so in this case, when K is 7, ARR of 7 doesn't exist. And that's why we get this error, right? So actually the code runs, so you see how we get all the output, but when K is 7, the program just stops running. And eventually everyone gets this error here. So yeah, it's an index out of bounds error. So it's pretty wild, students. So anyway, I do have one, maybe we can do one worksheet problem. Let's try one worksheet problem. And then we're going to talk about memory. Just a little bit of a long lecture here. So I'm going to stop sharing. And hopefully I did that. Any questions on anything? We'll just try one of these. If I have if I'm smart enough to put this up there, yes. So I have this worksheet. Let's see, maybe we can try. Why don't we try number 4? That sounds kind of interesting. And then we can do some more of this next time. I'll let you look at it, but we'll definitely do reviewing next time before we continue on. Okay, so write a for loop. We're gonna have to remember this, students, because I can't, yeah, I don't think, maybe somebody who knows more about Zoom than I do can share two files at the same. Seems like sharing one is, I wouldn't say bad enough, but it's kind of clunky enough. Okay, so write a for loop. I'm gonna copy this. And so we're just gonna display an array in reverse order. Okay. And there I say, let's assume that every element has a value, but let's just do, so I put real values in here. So let's just try this one. Okay, so I'm gonna go back to Eclipse now. Let's just use these values, or maybe we'll add stuff to it. The numbers don't actually matter, so I'm gonna share, I gotta share Eclipse again. And then we're gonna get to the real exciting part of today's class, memory addresses and arrays, which is one of the actually is a very, sometimes I say that a little facetiously, everything's important. But this memory address stuff is, if you understand it, it'll make your life a lot happier. Okay, so let's just wipe this out, okay? So we declare this, let's just put a few more values in there. So remember I said we can hard code the values. So let's just put a few more in there. See how easy it is I don't know, I'm not even looking. Okay, so we've got 5 values in there. Let's format this. I'm gonna go. Oh, we'll push it back. I just wanted to fix the spacing, but okay, so let's go back up here. And so what was so can I do this? Okay, enter, yes, okay. The only reason I'm doing it is because Zoom is taking up part of my screen. I'm not sure you see that, what I'm seeing. There's like this thing with green and red. Okay, so we want to just print this in reverse order. So that previous array we saw started at 0 and worked its way all the way up to a length -1. So what we're going to do, students, is we're going to start at, I'm not sure there really is a standard way when you're decrementing. So I'm going to just start this. So we're going to print out 100 first, and then 121, and then 45, 7, and 9. We're going to go backwards. So we're going to initialize k to the very last index. Well, the last index is always arr.length. It's the array name -1, then our semicolon. Let me just put the decrementer in there. It's going to be k minus, because we're going to go down. We have to decrease by 1 each time. And then let's put the Boolean expression in. And the Boolean expression is going to be k. Now, since some people will tell you that you should always use a greater than or less than sign. So if I was going to do that, I would put k greater. I have k greater than or equal to 0. We could also put k greater than -1. And I'll be honest, since I don't think there really is a standard way when you're decrementing. If I was incrementing, then it would be k less than arr minus length. And so now let's just print it out. But see how let me just put a space in there. Okay. Okay, so we start k out at, in this case, the length is what? The length is 5. Is that the number of elements in that list? 5? The length is 5. So k starts out at 4 because it's length -1. And while k is greater than or equal to, if k is greater than or equal to 0, we do whatever inside the for loop. So let's just, I shouldn't have gotten rid of that. I should have saved that. Let's just print the number. Say a little. So we're just going to go ARR. So it's actually going to print out the array values, not the indices, but the array values. And it's going to, it should print 100 first. And that's what it did. So print it out in reverse order. So we went from right to left. So we first printed out, you know what, maybe we should print out k. Let's print out k here so we can actually see we're going backwards. Let's take a second, then we'll talk about computer memory. So now, yes, it should be ARR 4 should be the first one. You see how the indices go down, 4, 3, 2, 1, 0. Yeah, and that's because, yeah, we started the K at length -1. And the value that makes is when K becomes, eventually, we're decreasing K by 1 each time. Eventually, K is going to be -1. -1 greater than or equal to 0 is false. And then we go to the, then we exit the for loop. So we'll do some more of these worksheet problems next time, and then I'll have a quiz for you to work on. Yeah, there's a few assignments up there. Hopefully it's not horribly time consuming, but it's new, but so it takes time, but this array stuff is really important. So if there's any questions, students, so this is the assignments I put on. I put on 2 programming assignments that actually are not with arrays. And I put up 2, they're almost identical. And one of them is a Zybook assignment, and they're really short. It's more to emphasize modulus and division. And if you can do one, I think you can easily do the other. So I'll let you read that. But yeah, I think it shouldn't be a lot of lines of code. And either altogether, inside the main method, the 2 programs together, I'm going to guess maybe 20 together, 20 or 25. So, and then I put a Zybook assignment up, just, with participation questions. And there are challenge activities. And I think the coding is not too bad. Just feel free to, if you get stuck, just contact me. And then we're going to have a quiz I'll post it on Wednesday, but you'll have several days to work on it. So, and then I have to grade your test. Yeah, I know, I'm really behind. I got tested in my other class too, I have to grade. But yeah, it'll hopefully grade it as soon as possible. But if there are any questions, let's get to the grand finale of today's lecture. So I'm going to stop sharing. We might come back to this eclipse just to show you. This shouldn't take too long, but this is a real kind of, let's see if I can find this. I think I put up this file called Arrays in Computer Memory. And I changed it because I think that's what I had in the slides, a little confusing. So hopefully, hopefully this won't be too confusing. The thing that's important about an array, what is actually, like if you look at this statement right here, what is actually stored in ARR? If you look at this statement, so everyone should see a file right now where the header is arrays in computer memory. So what's actually stored in an array variable itself? Let's say I use the array variable, not the square brackets. And it's actually, it's a computer address. So let's just review. We talked about this a little bit. You're not tested on this, but it helps if you understand it. The basic unit of storage in a computer is a byte. We all know about bytes. How many bytes of memory does your phone have? And we didn't talk about that when I was young, but now everyone knows about bytes. Okay, and every byte is actually assigned an address, just like houses and buildings have addresses. And actually, these addresses are integers, and they're huge integers, something, and they're expressed in what's called base 16 because they're so big. So instead of expanding the individual digits in powers of 10, we expand it in powers of 16. And so we're just going to pretend the addresses are small numbers. Okay, and so an array variable is actually assigned an address where we can find the first element of an array. Because remember, all these numbers, all this data that we work with, you assign a variable a value, that value is stored in the computer's memory, so we can remember to use it. Just like, a calculator has, we can store, all the numbers are stored in memory. So, okay, and an array tells us where we can find the actual data in memory. Okay, so let's just look at this example right here. Okay, so we declare an array with 5 values, and let's just, nothing exciting about the numbers that we're initializing it to, like 10 and 2 and 4, 6 and 99. Okay, and so since we never actually know what the memory address is, so I said, so like it's this statement right here. This is right there. What's happening there, students, is so we're allocating memory, that new operator, it allocates memory for 5 integers, And then you see that equals, it's an assignment statement. What we're doing is that we're assigning the memory address of where we can find these values to ARR. So new actually allocates memory, and the address of that memory is assigned to ARR. Okay, and there's no way we can find out. We can't print it out. If you actually try to print out ARR, you get some kind of funny symbol, meaningless junk. Okay, so, okay, but let's just assume that the address is 1024. Okay, so here's some what I call visualization, how the array is stored in memory. So just remember, every int value is allocated 4 bytes. So so ARR let's assume ARR is assigned a memory address 1024. So we rip our computer open and we look at its memory, and we go to address 1024. Oh, we see the 10. And then 4 bytes later, we see the 2. And then 4 bytes later, we see the 4. 4 bytes later, yeah, we see the 6. And then 4 bytes later, we see the 99. Okay, so the array itself doesn't store the values. It stores the address where we can find the values. And it's called indirect addressing. In C, you probably haven't programmed in C, but if you have, it's like a pointer in C. And if we can understand that an array actually stores an address, life becomes a lot easier for us in the Java world. So, okay, so here's where we get this gotcha. Here, it's really quite important. Suppose 2 arrays are assigned the same memory address. And I'm right here, where it says very important. Changing a value in one of the arrays automatically changes a value in the other array, which is kind of weird. It's like okay, so let's just look at this example right here. And this will become important later on when we talk about methods. Okay, so now we declare this new array right here, ARR1, and we're going to assume it has 4 values. And now I am just going to assume that ARR, the data for ARR is initially stored at address. The initial address is 2048. Again, we never know because every array variable is assigned an address where we can actually find the data. We don't know what those addresses are, but we're going to assume it's 2048. And now, students, look what I do right here at this line right here. We're declaring another array. This is a little weird. We haven't done it. We're just assigning another one-dimensional array to it, or another integer array. ARR1 refers to a list of integers. ARR2 also refers to a list of integers, so that's a very valid assignment. ARR1 and ARR2 are variables that can refer to a list of integers. So I can assign one to the other. So now what happens is, in this statement right here, ARR1 and ARR2, they're both assigned a memory address 2048. So now if we actually, let's just print out the values in ARR1 and ARR2. It's this, we actually, notice how we have not explicitly assigned values to ARR2, but they both refer to the same address in memory. So when we print them out, they both have the numbers stored in their arrays are 11, 14, 9, and 6. These values that we assigned right here. And now here comes maybe one of the hardest things I think we've done so far. This statement right here, we're going to assign ARR2 of 1 is 20. But you know what, students? They both ARR1 and ARR2 refer to the same address in memory. So it's like 2 people who work on the same Word file. If one person changes the file, the other one notices the changes. So let's say 2 of us, I don't know if you ever worked like on a Google Doc where we're both in remote locations, but we're working on the same Google document. If I change it, then you're going to see the change as well, even though you haven't done anything. So we change AR2, we change the element 1 of AR2 to 20. Well, you know what? That actually changes AR1. This is where you get that side effect. And now we print them. Now let's just print the array values out again. We change AR2 and noticed it also changed AR1. Maybe and I have this really great visual. I'm praising myself. I don't know if it's a great visual. So here we have memory address. Okay, so here's memory address 2048. And initially, restored. And then I see array values for AR1 and AR2. And initially the values were 11, 11 is actually stored at address 2048, right? Isn't that what the numbers we initially assigned? 11, 14, 9, and 6. And then we assigned 14, initially a 14, and then 9 and 6. And then when we changed AR2 of 1 to 20, that automatically, well, it changed what was it at, it changed the value in memory. So AR1 automatically sees that change. So this is kind of a, so this is kind of a little bit tricky. You don't really, can I still tell you students, we don't really write code like this. But eventually what we're going to be doing is we're going to be working with methods and arrays. And then this will come up. And this is the whole concept of an array storing an address is really important to understand what we're going to do really for the rest of the course. So, you might need to think about this or work on some problems to let it sink in. But are there any questions right now? So I did post the Zybook assignment. I don't think I put it on. I would start there with the Zybook assignment and then look at the worksheet. We'll review the worksheet next time if you want to look at those problems, but I'm going to post a Zybook. It is available on Zybook and I'm going to make sure it's listed on Canvas. I can't remember what I did like 5 minutes ago. Okay, but I'll double check that. But are there any questions right now? Is it okay to, like, any questions on this document? And students, if you think this is hard, what I'm talking about is because I think it is hard. This is the hardest thing we've done so far. But I think everyone's capable of understanding it. You just have to, it just takes time, students. It's like anything. Math is hard. I think math is hard. So are there any questions right now, students? I'm going to stay here until there are no more questions. And then when everyone goes, I want to make sure that the Zybook assignment is there, and I'll create a module. I want to make sure all the files are online. I want to make some revisions to some of the files I put on. But so I'll stay here until there are no more questions. I'll be like the last person to leave the room.
I just had a quick question.
Yeah, go ahead.
At what point are we going to be able to like extract data from an external file? Or would that be like a Math 140 kind of?
No, I think there's a unit on that. There's like a, is this Jose or I'm trying to?
Yeah.
Okay. You probably asked me about my least favorite topic. It's not that there's anything wrong with extracting data from files. It's a question of where is the file located on your computer? And sometimes, trying to help people, you can actually put like a complete path to the file, which I really tend to, I discourage. And so like, I work with these two IDEs, Eclipse and NetBeans, and their default locations are in different places. And it just drives me crazy. Where is the default location for the file? So soon, I think there's actually a unit on that. We're done. It's really not that hard. It's and I can even if you want to go ahead and do that, I can try to find out get that information to you. It's that system. You know how we do scanner? We go like new scanner system in.
Yeah, when it says import.
Yeah, so system in means the keyboard. So instead of going system in, you just actually put like a path to a file. And then you can just start, and then all the print and the print lines, or no, all this stuff is, all like those statements like scanner.next in, scanner.next, everything stays the same.
Is it usually meticulous with the format of, say, like an Excel or in the? No,
it's not really. Oh, no, the only thing is our output, but I mean, in terms of the file format, is that what you mean?
Yeah.
Or, no, this is one blank space in between numbers or 20 blank, no.
Or cells or anything?
No, we just have to make sure the file has the correct, like maybe it might have to have the correct number of, like for each line might have to be formatted in terms of, let's say we're reading in a string and then a number on every line. We just have to make sure our file follows that format. But like the number of spaces in between what they call, I think they're called like tokens, between terms, No, you can have as many spaces as you want. The
Okay.
file itself can be, you just have to make sure that the data in the file conforms to the data that you're trying to read in. So if I read in if I'm trying to read in like a string and then a number and a number, you better have that on every line of your file.
Okay,
It's not really that hard to do. You just make sure, because it's your file, you just make sure it's right. Or if you get the file, you just make sure your program conforms to that.
all right, thank you.
Oh yeah, anything else?
I don't think so for right now.
Okay, well, just write me if you need anything.
Thank you. Have a good one.
Yeah, you too. Bye-bye.